Alright, so for today, we're going to continue our discussion all about projectile motion, and we're going to talk about the horizontal range and the maximum height. So if we want to find the horizontal range R and maximum height of the projectile in a symmetric path, we can use the formulas R, which stands for the horizontal range. This is the maximum horizontal distance that the projectile has traveled along the x direction. So that is equivalent to v naught squared, which is the initial velocity squared, sine 2 theta, where theta is the angle of launch. So you're going to multiply it by 2, evaluating the sine, divided by the acceleration due to gravity. And for the height, we have pretty much the same formula. So height is equals to v naught squared times sine squared theta over 2g, or v naught squared quantity sine theta squared, okay, divided by 2g. Now, let us take note that these two formulas can only be used when the launching heights and the landing heights are equal. Okay, just like our previous example from our last video, wherein we have answered this problem, wherein the launching height has the same level as the landing height. Okay, so we can only use these two formulas again when the launching heights and the landing heights are equal. Okay, so based from these equations, the horizontal range is maximum at an initial angle of 45 degrees. So as you can see here in the graph, a projectile is fired, okay, at different angle of launch. So for 15 degrees, it reaches until here. For 30 degrees, it reaches until between 200 to 250 meters. At angle of launch that is 60 degrees, it reaches the same as for the 30 degrees. And at angle of launch of 75 degrees, reaches only the same for 15 degrees. So it is actually visible in this graph that we can maximize the horizontal range if the angle of launch is 45 degrees. So as you can see in the figure, that the projectile has traveled a horizontal range more than 250 meters. And that is because of the equation of the horizontal range. Okay? So if 45 is our theta, no matter what is our initial velocity and this acceleration due to gravity is constant, so sine 2 theta, that is to say sine 2 times 45 is sine 90. And sine 90 is always equal to 1. So we would be having a maximum range if the angle of launch is 45 degrees with respect to the positive x-axis because of this term. Okay? So because any theta that is below 90 or greater than 90 would give you a value of less than 1. Okay, and if we multiply less than 1 to V naught and divide it by G, so we will be having a smaller value of range. Okay, so please take note of this formula, horizontal range and H. And again, to clarify, these formulas can only be used if the landing height and the launching height are the same. Okay, the same level. So let's try to solve some problems. A long jumper leaves the ground at an angle 20 degrees above the horizontal at a speed of 11 meters per second. So oops. So what are we going to do here is, first, to solve this problem, we could write the given v naught, initial velocity of the jumper is 11 meters per second. So 11 meters per second. And the angle at which he leaves the ground is 20 degrees above the horizontal. Okay, the question is, how far does he jump in the horizontal direction? So how far? That should give you what is the horizontal range or the range by this jumper. Okay? So we can calculate the range by our equation V naught squared sine 2 theta divided by G. So V naught is 11 meters per second squared sine twice of the angle, which is 20 degrees, divided by 9.81 meters per second squared. And that should give us an answer. We're going to calculate it 7.94 meters. Okay? So that is for letter A. For letter B, it says, how far does he jump? Or what is the maximum height reach in letter B? What is the maximum height reach? So maximum height reach can be calculated by the formula H is equals to V naught squared sine squared theta over 2G. Or we can simply write this term as V naught squared sine theta squared, because you will be having a trouble writing this formula in your calculator. So this term is equal to this. Okay? So let's try. H is equals to 11 meters per second, that is squared, times sine 20 degrees squared divided by twice the acceleration due to gravity. Yeah. So we shall get an answer of 0.722 meters. Okay, the maximum height of the long jumper is 0.722 meters, and the range, horizontal range, is actually 7.94 meters. So we have used this formula because we assume that the uh, launching height and the landing height are the same. Okay, so let's go to our problem. So in problem number 4, Engineer Abat tossed a ball from his window 8 meters above the ground. When the ball leaves his hand, it is moving at 10 meters per second at an angle of 20 degrees below the horizontal. So I am at the top of the building. I tried to toss a ball. So at velocity 10 meters per second at an angle 20 degrees below the horizontal. That means I will be having a negative angle here because it's below the horizontal. So how far horizontally from your window will hit the ball? Will the ball hit the ground? So let's try first to draw. I hope I could draw legibly here in my Wacom tablet. So for example, this is the building, and this is our horizontal. Okay, so 20 degrees, oops, 20 degrees below the horizontal, I fired the ball, or I tossed the ball. Okay, and the height of this building, according to our problem, is 8 meters above the ground. Okay, this is 8 meters. So this angle with respect to the positive horizontal should be negative. Okay, because I'm having my reference angle here in the horizontal x. So my direction is clockwise, so that should give you a negative angle. Okay, so after that, the problem is actually asking what is the distance x traveled by the ball when I toss the ball 8 meters from a building, okay, above the building, so above the ground. So let's write the given. So we have a v naught of uh, 10 meters per second. 10 meters per second. So the problem is actually asking how far horizontally from your window will the ball hit the ground. So from my window, will the ball hit the ground to this final destination? How far is that? That is the problem. Okay? So, my question is, can we use the horizontal range formula here? The answer is no. Because the launching height, I'm here at the top of the building, and the landing height are not the same. So definitely, the range R, or the horizontal range formula, cannot be used. So you still have to use the knowledge in your projectile motion. So again, we're going back to those four equations. Okay, so those four equations are x is equals to v naught cosine theta t. So we have y v naught sine theta t minus 1 half gt squared. So we have velocity for x, that is v naught cosine theta. Vy is simply v naught sine theta minus gt. Okay. The problem is actually asking for the horizontal distance from my building to the final landing distance of the ball. So I have to use x, okay, because that is the question. However, if I'm going to use x, we are given by the v naught, that is 10 meters per second. We are given by the cosine theta, that is negative 20 degrees, but we don't have the time. Okay, so we're going to use the given in order for us to find the time, and then we're going to multiply that time to this so that we can get the x. Okay, so from our formula, second formula, we have y v naught sine theta t minus 1 half gt squared. Okay, so let us realize that this y, since we have here, if you're going to have an origin here, if you're going to have an origin here, okay, such that we labeled it as an x and y coordinate. So if we have an origin here, 8 meters below, and that should be equal to negative 8. Okay? So because it's below the origin, if we're going to take this also as an origin, still 8 meters below is negative 8 by the convention of the coordinate system. So times v naught sine negative 20, that is times t, we don't know the time, minus 1 half 9.81 t squared. So if we're going to evaluate this, 10 sine negative 20, 10 sine negative 20, that is negative 3.42 t. And if you're going to evaluate, my mistake. If we're going to evaluate this, negative 1 half of 9.81, that is negative 4.905 times t squared. We don't know the time. Okay, we really don't know the time. So what are we going to do here is to simply arrange this. Okay, let's try to transpose this term on the other side of the term and this term on the other side of the equation, I mean. So 4.905 t squared plus 3.42 t minus 8 equals to 0. So if we are going to solve the roots of this equation, we shall be arriving at two values of time. Okay? So we're going to use this. We're going to have this as our A, have this as our B, have this as our C. We can use the quadratic equation in order to find the roots of this equation. Okay? So if we're going to apply this, for example, let's try to apply first, diba? Let's try t sub 1, that is negative of 3.42 plus, let's try to evaluate first the plus b squared, which is 3.42 squared minus 4 times 4.905 times c negative 8. Sorry for my bad handwriting. I'm not really used to my digital writer. Okay, Wacom 2 times 4.905. So evaluating that, let's try. Just give me a minute, a second. I mean, I think it should give us positive value. So that is equivalent to 0.98 seconds. So if we wish to evaluate the other root, t sub 2, we shall have 3.42 minus the square root of 3.42 squared minus 4 times 4.905 times negative 8 divided by 2 times 4.905. Let me just calculate it again using our calculator. So it's very important to have always your calculator with you when solving physics problems. So that should give us negative 1.67 seconds. And we could not accept this as a valid answer. Why? Because there is no such thing as negative time. So our answer should be 0.98 seconds. Now, this is the time of flight of the projectile. Okay? That is not really yet the final answer. So, if we wish to go back to our problem, the problem is actually asking what is the horizontal distance traveled by the ball, okay, from the building. So, using this formula, we have 10 meters per second times cosine of negative 20 times time, that is 0.98. Okay, so our answer should be 10 cosine negative 20. Let's check if I have correct answer. 9.21. So 9.21 meters. 9.21 meters from the building. The ball has traveled. So we have a correct answer here. Okay. So again, we cannot use the horizontal range formula or the maximum height because the launching heights and the landing heights are not the same. So I hope you are learning in our discussion. So down to our last example. So a stone is thrown from the top of a building upward at an angle of 30 degrees to the horizontal with an initial speed of 20 meters per second. Okay, so as shown in the figure, so we have here a from the top of the building that is 45 meters above the ground. So the man tosses a stone that is directed 30 degrees with the horizontal. So the problem is actually asking how long does it take the stone to reach the ground. So how long? Okay, so definitely we're going to go back in our equations. How long? So we're going to eliminate this Vx because it doesn't have any time in it. So we are left with these three equations. Okay, so we don't know. We cannot use this first equation. Why? Because we don't know when you throw the stone, we don't know the value of x. Okay, so we will be having two unknowns here. So definitely this is not the equation to be used here. Okay, so we have also an unknown here. We don't know the velocity along y. Okay, so definitely we're going to use the second equation, which is y is equals to v naught sine theta t minus 1 half gt squared. Pretty much the same as what we have did a while ago. V naught sine theta t minus 1 half gt squared. So we have the given V naught. V naught is actually 20 meters per second. So that is 20 meters per second. We have the angle of launch, that is 30 degrees. And also, we have the height of the building, which is y, let's represent that as y, is equals to 45 meters. Okay, back from the figure. Again, choosing this top of the building as our origin, down below the origin, this height should be what? Negative. Okay? So, going downward from our convention in a coordinate system, that should be negative. Okay? So, if you're going to substitute, negative 45 is equals to 20 times sine of 30 degrees times time. We don't know the time. Okay? So, minus 1 half 9.81 t squared. Again, evaluating this, negative 45. We have 20 sine 30 and that is 10t minus 4.905 again t squared. So we have evaluated 1 half of 9.81. So transposing these two terms to the left side of the equation. So 4.905 t squared minus 10t minus 45 is equals to 0. And again, we have a quadratic equation here, labeling this coefficient as A, and this as B, and this as C. So if we wish to find, again, the roots of the equation, of that equation, we shall be using the quadratic formula. So E is equals to, let's T sub 1, negative of negative 10 plus, let's try, B squared, negative 10 squared minus 4 times 4.905 times C, that is negative 45, divided by 2 8, 4.905. Let me just try. So 10 plus square root of negative 10 squared minus 4 times 4.905 times negative 45 divided by 2 times 4.905. So, and that should give us an answer of t sub 1, 4.22 seconds. And if you're going to calculate the other root for time, so we should calculate also the other root for the time, t sub 2, in order for us to validate our answer. So t sub 2 should be negative of negative 10 minus square root of, still the same, so negative 10 squared minus 4 times 4.905 times, negative 45 divided by 2 times 4.905 and that should give us an answer of, I think, a negative value, which is then again not accepted because there is no such thing as negative time. So the time it takes to reach the ground is 4.22 seconds, as we have here as an answer here in our problem. So letter B, what is the speed of the stone just before it strikes the ground? Okay, just before it strikes the ground, okay, the speed of the stone is actually what? The magnitude of the velocity along x and velocity along y. So take note that the problem is asking for the speed. So that is basically the magnitude of bx and by. So in order for us to get that, so what is the speed? We need to use the vx, v naught cosine theta, and we need to use the vy, v naught sine theta minus gt. So if we use this, our v naught is 20 meters per second. Have we used 20 meters per second? Yes. So 20 meters per second cosine of 30 degrees. Cosine of 30 degrees. That is our velocity along x. 20 cosine 30 is 17.32 meters per second. That is the velocity component along x. Okay, so let's try the vy to solve for vy. 20 sine of 30 degrees minus 9.81 times the time. Okay? The time it takes to reach the ground. So that is the velocity of the object or the stone just before it hits the ground. Okay? So what is our time a while ago? Our time is 4.22 seconds. 4.22 seconds. So if you wish to compute that, 20 sine 30 minus 9.81 is 4.22. It should give us negative 31.3982. That is the point, meters per second. And if we wish to calculate the speed, that is basically the magnitude of bx squared plus by squared. So the magnitude is simply 17.32 squared plus negative 31.3982 squared. So if you get that, 17.32 squared plus 31.3982, doesn't matter if you include the negative sign because it's squared. So definitely we will not be having a problem regarding that. So 35.86 meters per second. And let's check if our answer is correct. Yes, that is correct. 35.8 meters per second. That is the speed of the stone just before it hits the ground. So here are our references for our lecture. So I acknowledge our references: University Physics 1, Calculus Base by Raymond A. Survey and John W. G. Webb, and actually the University Physics with Modern Physics by Young and Friedman. So thank you for listening and God bless, and I hope you enjoy this video. If you find this video helpful, please don't forget to click thumbs up and subscribe to my channel. Thank you so much.